Hey everyone, and welcome to The Explainer. Today we are diving into a pretty incredible technology that honestly is kind of like a superpower. The power to see what's invisible to the naked eye. I mean, just think about it. What if you could look at a rock or a piece of jewelry, maybe even a sample of soil, and just know exactly what it's made of, right down to the elements, without doing any damage to it whatsoever? Well, believe it or not, that power isn't science fiction. It's totally real, and it's being used every single day in fields you might not even think of.
Okay, so let's get into it. The tech is called X-ray fluorescence, or as everyone calls it, XRF. It's all about seeing the unseen elements that make up the world around us. Now, the most important phrase in that whole definition is non-destructive. That means you can analyze, say, a priceless historical artifact or a critical sample for quality control, and it comes back completely unharmed. It's an absolute game changer. So how does it actually see inside stuff? Well, it all comes down to something called an elemental fingerprint. Every element has one.
The physics behind it sounds complicated, but we can break it down. First, the XRF machine shoots a high-energy X-ray at your sample. This hits an atom and gets it all excited, so excited that it knocks an electron out of its cozy inner shell. Now there's an empty spot. So, an electron from a higher energy outer shell immediately drops down to fill the gap. And when it drops, it releases a little burst of energy as a brand new X-ray. And that, right there, is the magic. The energy of that new X-ray is totally unique to each element. Iron has one energy signature, gold has a completely different one, lead another. The machine detects these unique energy signatures, these elemental fingerprints, and that's how it can tell you exactly what's inside your sample. Of course, if you want to get a clear fingerprint, you need a clean clue, right? This is why preparing the sample correctly is so important. It really doesn't matter what you're testing. Could be metal, could be powder, could be a liquid. The goal is always the same. You need a nice, uniform surface that the X-rays can read reliably. Any bumps or dirt or just inconsistencies, they can really mess up the results. So for solid stuff, like a piece of metal, you'd probably grind or mill the surface until it's perfectly flat and smooth. Now for powders, it's a little different. You'd crush up the material and then press it into a hard, flat little pellet, almost like a tiny little coin. And yep, even liquids have their own prep method. They go into a special little cup that has a super thin film like mylar stretched across the bottom. The X-rays can shoot right through that film to analyze what's in the liquid. For all of them, though, the goal is the same. Make the sample steady and clean to get a reading you can actually trust. All right, the sample is prepped, the machine has zapped it, and now we get that aha moment. It's time to read the results and figure out what we're looking at. What you get from the machine is a graph called a spectrum, and it's actually pretty easy to read. See a peak on the graph? The position of that peak tells you which element you found. And how tall is the peak? That tells you how much of that element is in there. Simple as that. But, it's not always quite that simple. Just like in a good detective story, sometimes the clues get a little jumbled. Scientists call these interferences, and it's basically when the signals from different elements can overlap or even create false readings. So how do they solve these little mysteries? Well, they have a whole toolkit of fixes. If two element peaks are blending together, they use special software to mathematically pull them apart. If the detector gets overwhelmed and creates a fake sum peak, they can just turn down the X-ray intensity. And for something called matrix effects, that's when all the other stuff in the sample messes with the signal, they use smart software corrections. It's a cool mix of good physics and even better software. So now that we have a handle on how it works, let's talk about the fun part. Why XRF is such a critical tool in so many different fields. So how many fields are we talking about? Well, at least 9 major ones, and honestly, that's just scratching the surface. The applications are all over the place. I mean, you've got miners using it to analyze ore right there in the field. Oil refineries use it to check for sulfur in fuel. Environmental agencies use it to test soil for dangerous heavy metals. Recyclers use it to sort valuable metals and alloys. Manufacturers use it to make sure their electronics don't have banned chemicals. It is, quite literally, everywhere. And that's another really key point here. XRF isn't just stuck in a lab. Sure, there are big, powerful lab machines, but there are also these portable, handheld XRF guns that let you take the lab with you, whether you're at a construction site, a scrapyard, or out in the middle of nowhere on a geological survey. So when you boil it all down, it comes to this. XRF gives you fast and reliable answers.
It's a safe and trustworthy way to figure out what elements are inside almost anything, without having to break your sample to find out. So the next time you look at something and wonder, what is that really made of? Just remember, there's a technology that can tell you. It's a real-life superpower for seeing that invisible elemental world all around us. So what would you point it at?